Hello everyone. Today I'd like to talk about the relationship of the current passing through a resistor and the power dissipated from it. My objective in conducting this experiment was to show the current equivalent resistance relationship and how the current would change inversely proportional to the equivalent resistance, and also express the relationship between the current and power dissipated, and show that the power would be proportional to the square of the current. For the theoretical background, I use the formula for the R equivalence for the series connections, and also Ohm's law, which is V equals I times R, and the formula for the power, which is I times V, and can be derived as I squared times R, V squared over R. For the setup and procedure, I use the voltage supply, which I arranged as 5 volts, a multimeter I used as an ammeter, another multimeter I used as an ohm meter, crocodile cables, and light bulbs. I first started by measuring the resistances of each and every bulb and the equivalent resistances after that. Here is a video of me making those measurements. After finding out the resistance values, I connected the bulbs to the circuit one by one and observed how the brightness of the lamps reduced. And also I recorded the current values to my data tables. Here are my data tables, and the first one is the variation of equivalent resistance with respect to the increasing lamp count. I'll explain the errors later on. Another data table for the variation of current with respect to 1 over R equivalent. Another data table for the voltage levels and the graph I plotted, where I can see that the current is inversely proportional to the resistance, and that's why it's directly proportional to the 1 over R equivalent. And the last data table I had is variation of the power dissipated by a bulb with respect to the current passing through it. And here's the graph for it, showing that the power changes with respect to the square of the current. I obtained some errors, and for the resistance, I can say that I had some measurement mistakes done by me, and also some of the bulbs had loose contacts, causing me to measure them wrongly, and the ohm meter might have some inaccuracy due to previous measurements. The current, I also had some errors ranging from 2% to 30% due to measurement mistakes, and mostly due to the increasing temperature of the resistances, causing me to get different results, and perhaps the previous measurements might have caused a meter inaccuracy too. And the errors I got for power and voltage can be also explained due to resistance and current, since I derived them from those values. And I can say for results that the power dissipated by a bulb was roughly its resistance times the square of the current, and the current changed inversely proportional to the equivalent resistance. So thank you for listening to me, and here are my references.